Hello, welcome to Jemason Tutorials. In this question, we have that a delegation of 2 men and 4 women is to sit in a row for a meeting. In how many ways can they sit if A. There are no restrictions, B. The men must sit together, C. The men must not sit together, D. The men must sit together at an extreme. So when you look at the question, we have 2 men and 4 women, a total of 6 people involved. And the issue is that they are sitting. And how are they sitting? In a row. Those are the key words in the question. Anything that has to do with people sitting, it means they are going to be doing arrangements as they are sitting. So we are dealing with permutations here. Permutations have to do with arrangements. And in a row, we have to look at a way of treatment that goes with that too. Linear arrangements, because a row simply means in a straight line. Okay, we start straight away. In the A part, they say their sitting has no restrictions. In a situation where you have to arrange n distinct objects in a row without any restrictions, you simply use the formula, the permutation formula. In this case, there are 6 people to arrange, and we are taking all of them to arrange. So number of ways equals 6 permutation 6. That is equal to 6 factorial all over 6 minus 6 bracket factorial. This gives 6 factorial all over 0 factorial. So 6 factorial is supposed to be 6 times 5 times 4 times 3 times 2 times 1. And that is supposed to be 30 times 4, which is 120. 120 times 6, that should be 720 ways. So that is one way of looking at the problem. Another method that we could also use would be analytical, where we consider the different ways that we can arrange the people in a row. We consider the different ways in the different positions and then multiply the options to arrive the answer. And that option is usually appropriate for questions that have restrictions. Where there are restrictions, the formula method becomes restricted. Take note. And so the second method I'm going to use here should be the one that you adopt anytime you see a question involving restrictions. In that second method, we look at the positions of the people diagrammatically like this, and then 1, 2, 3, 4, 5, and then 6. We look at the first position, second, third, fourth, fifth, and then sixth. Now, in order to arrange a person, or for a person to come and take the first position here, if I go to that group of 6 people, the 2 men and the 4 women, I have 6 options of taking somebody to come and sit in this first position. So in the first position, we can arrange it in 6 ways. When that one person out of the 6 has been arranged in the first position, if I go back, I will meet but 5 people left in the group. And so to arrange a person in this second position, I will need to choose from 5 people. So I have 5 ways of filling this second position. And the number of positions will keep reducing as the number of people are coming and sitting. So if I go back to get the third person, I'll meet 4 people there. And in the fourth position, when I go back, I will meet 3 people to select one of them to come and fit and sit in that position. And so on until the fifth. I will have 2 options of taking a seat in that position. And then the last option will just be one way, because when I go back to take a person to come and take that seat, it would just be one way, as I'll meet only one person at that point. So number of ways. Now if you look at this, you will see that the analysis goes like this. The first position can be taken in 6 ways, and the second in 5 ways, and the third in 4 ways, and the fourth in 3 ways, and the fifth in 2 ways, and then the last in 1 way. Where you analyze a question and the options that are in the question, usually the number of ways of arranging the various positions, are linked by the word "and", then you have to multiply the options. This is in accordance with the fundamental principle of counting. And so I will say number of ways equals the number of ways of arranging somebody in the first position. So 6 times the next position times 4 times 3 times 2 times 1. And that gives us again the result we had up, which is 720 ways. So note again, when you see a question that involves especially restrictions, be it permutations or combinations, you analyze the situations, and if you notice that the options that are in the question are linked by the word "and", then you are going to multiply the options, the number of ways of getting those options, in order to arrive the answer. When it involves being linked, the options being linked by the word "or", then you are going to add the options. All these are in accordance with the fundamental principle of counting. So it is important to know. Now we go to B. So we have A, the 2 ways of solving. In B, the question says the men must sit together. For them to sit together, there are again different options that you can look at the question. One way would be to make a diagram. So I have 2 men. I will label them as M1 and M2. And the women will be W1, W2, W3, and W4. One way of looking at the question would be to consider the men as a block. They have to sit together, remember. If I consider them as a block, then I would first get how many ways they can be arranged themselves, because as they are coming to sit together, there are also an arrangement that can take place between them. You can have the case where the second man is sitting in front and then the first man is sitting behind. In short, to arrange n objects in a row in a straight line, we simply, number of ways we obtain is n factorial. So there are 2 of them, and we need to consider their arrangements before considering again the arrangements that they will do as they are coming now as a block to arrange themselves with the women. So that implies that I take the men as a block, then add to the number of women, and then do an arrangement as if it was 5 people I was arranging. So that is one way of getting that number of ways. It means I'll have to say number of ways equals 2 factorial. That means the number of ways of arranging the men, as I said again, as they are coming to sit together, and usually they will be sitting in between the women and so on, arranging themselves. They arrange themselves as they are sitting together between the women in order to be as a block, in order to be together in 2 factorial ways, times now the number of ways that you can combine the men as a block with the women and do an arrangement as if it was 5 people who were sitting together, which is in 5 factorial ways. That gives us 2 factorial is 2 times 1 times 5 times 4 times 3 times 2 times 1. And that gives us, in short, the 2 factorial is 2 and 5 factorial is 120. So that gives 2 times 120, which is 240 ways. Another way of looking at the question would be looking at the way we can arrange the women first, and looking at the way we can arrange the men also, and then looking at the way the men can come and fit themselves amongst the women. So we could also talk of the men can be arranged as they sit together in 2 factorial ways. The women can arrange themselves in 4 factorial ways. So there is an arrangement for the men as they are coming to sit together. There is also an arrangement for the women because they can change their various positions. Usually when it is being arranged, usually when people are being arranged in a row, you have to use just n factorial. So the women themselves can do some arrangements as the men too are coming to sit in between them. So the women will arrange themselves simply in 4 factorial ways. Then the men can sit together between the women in, we look at it this way: if the women have sat down, whatever arrangement they would do, the men would just have 1, 2, 3, 4 and 5 options of taking a position as a block because they have to sit together in between the women. So we have 1, 2, 3, 4, 5 ways that the men can sit together between the women, and that is 5 ways. And so number of ways men sit together amongst the women would be all the options multiplied. The men can arrange themselves as they sit together in 2 factorial ways, and the women can arrange themselves in 4 factorial ways, and then the men can sit together between the women in 5 factorial ways. The options are linked by the words and, so we multiply. So we have 2 factorial times 4 factorial times 5 factorial. That gives us 2 times, no, this is not factorial, times 5. 2 times 5, then times 4 factorial, which is 24. That gives us 10 times 24, which is 240 ways. Again, as before. We move to C. the men must not sit together. Okay, in the case where the men must not sit together, there is a shortcut method for getting it, since we already know the method in which, or since we already know the number of ways in which the men can sit together. So in this case, I will just say number of ways the men would not sit together equals number of ways they would sit at random without any restriction minus the number of ways they would sit when the men have to sit together. So when you do that subtraction, you will get now the number of ways that the men can sit without being together. So we have 720 minus 240, which gives 0, 12, that's 8, and then 6 minus 2, 480 ways. There is another way of looking at it too. We consider the number of ways first that we can arrange the women. So we say or the women can sit in 4 factorial ways. So the women would sit first, then since the men don't have to sit together, I will first take the first man to go and sit. The first man going has to take any of these positions. So he has to sit in 5 ways. So the first man can sit in 5 ways, and the second man can sit in 4 ways. So when the first man is going to sit, he has 5 options to take, either in front, between the first and the second woman, between the second and the third woman, and between the third and the fourth woman, or even at the end. So 5 options for the first man going. When he has taken a position, then the next man coming, since he cannot sit again where he's sitting, they shouldn't be together. You will now have the other 4 options to take so that they don't be together. And so these are the different ways. We now say, so these are the different ways, and from there now we'll say number of ways. Again, you can see that the options here are linked by the word and. The women can sit in 4 factorial ways, and the first man can sit in 5 ways, and then the second man can sit in 4 ways. So multiply the options again to have 4 factorial times 5 times 4. That gives 4 factorial, which is 24 times 20, which still gives you 480 ways as before. Then in the D part, it says the men must sit together at an extreme. Again, we do the analysis as we did for this other case. For the men to sit at an extreme, they are sitting together at an extreme, so we have to also make an arrangement for them again, which is in 2 factorial ways, because they can be going to any of the extremes, which are 1 and 2. The extremes are either in front or behind. So they are coming to sit together in 2 factorial ways, and they can fit themselves between the women. They can fit themselves at the extremes in 2 ways because there are 2 extremes. And then we also consider the arrangements for the women and then multiply the options. So we say the men sit together in 2 factorial ways. It's either the first man before the second or the second before the first. So 2 factorial ways. The women sit in 4 factorial ways. The women have to arrange themselves as they are sitting in 4 factorial ways. And then the men can occupy the extremes in 2 ways. So number of ways equals 2 factorial times 4 factorial times 2, which gives 2 factorial times 2 is 4. So we have 4 times 4 factorial, which is 24, and that gives 96 ways.